For this example, we are going to prove that the quantity of the sine x plus cosine x squared equals 1 plus sine of the double angle x. The guidelines to prove trig identity, we will work on the side that has more complicated term. Use appropriate trig identities, replace them, and simplify. And eventually, we're going to have exactly the same term or the same expression as the other side that we did not start with. For this one, we're going to start with the left-hand side. So left-hand side, we work on sine x plus cosine x quantity squared with the power 2. Note the power 2 or the perfect square x plus y quantity squared, which is from x plus y times x plus y. Expanded using void, we will get x squared plus double of the product x and y plus y squared. For this case, the square of sine x plus cosine x will give us sine square x plus 2 times sine x cosine x plus cosine square x. We're going to rearrange the terms since we see the cosine square and sine square. Recall the trig identity that we used a lot would be sine square x plus cosine square x equals 1 or the Pythagorean identity. Now we're going to rearrange the term, move them next to each other for our convenience. The sum of sine square and cosine square x will give us 1 plus 2 times sine x cosine x. Recall the 2 times sine x cosine x is equivalent to sine of double angle, or sine of 2x is 2 times sine x multiplied by cosine x. This portion becomes sine of double angle x and then added by 1. Now we have exactly the same expression as the right hand side. And we are done proving.